There seems to be a little bit of confusion surrounding the difference between a monohybrid cross and a pedigree. If you think about it, a monohybrid cross would be done something like this. The parents would be put into boxes and crossed with each other. Let's take an example like the Mendel one. It's very interesting to know that it's the genotype that you're writing in the box. The genotype that you're writing in the box. And we represent the parents in squares. If we come down to the gamete, we're again writing the genotype of a gamete. But we're putting the gametes as circles. This is just a convention that is commonly accepted. So we have boxes and circles. Inside is a genotype. That's for a monohybrid cross. When it comes to a pedigree, however, things change. A pedigree is the phenotypic expression of a family tree. So it's phenotypes in a family tree. So now it's also important to remember that any pedigree needs a key. In a pedigree key, what normally is the case is that males are represented in squares and females are represented in circles. And if a gene is expressed, they normally shade in one of the two boxes. So let's say, for example, that black fur is what is expressed in this case. This would be a male with black fur, where this would be a male with, let's say, brown fur. And this over here would be a female with brown fur, and this would be a female with black fur. And then, knowing that key, we can look at the actual expression of a particular family. So let's say, for example, we choose a male, and that male gets crossed with a female, and both of them have the expression of black. Now let's say these parents have 4 children. And let's say there were 4 male children. 3 male children and 1 female child. So that's not unusual. Now that is not a probability, that is the actual situation. And let's, for argument's sake, say the female had black fur, and we know this because she was expressed as a black-furred individual. This particular male had brown fur, this male had brown fur, but this male had black fur. Now I'm just picking these at random. So a pedigree is not something that you can work out. This is actual individuals of an actual situation. It's nothing to do with probabilities that you would see in a monohybrid cross. And from this, you can see that there are 2 generations being expressed. The first generation being the parents, and the second generation of their offspring.
And they can carry on going down, going down, going down.
It's probably important for you to go and look at the pedigree of the royal family in hemophilia. Look that up, or look in your notes, you'll see a very, very good example there. But what's very easy to do on a pedigree is to quickly work out what is the genotype of any particular individual. Now, I did this on purpose. If we take this particular pedigree, we can actually work out the genotype of the individuals here without knowing which is dominant, black or brown. But let's take a look at it. If we have a black individual and a black male and a black female, and they have these children, they are going to be passing down that black gene to their children. Let's just assume, first assumption I'm going to do is, let's say brown is dominant. So I'm going to make this assumption and see if it works. So assuming brown is dominant and black is recessive, Let's see if we can actually use this information in this particular pedigree. Right, Brown being dominant. Let's look at the children first of all. With Brown being dominant, we know that these two boys have to therefore have a capital B. They could be homozygous, big B, or heterozygous, big B, small b. You also have to consider that that big B came from somewhere. So it came from one of the parents. So let's go and assign that to one of these parents. Let's say that the father was big B. Immediately we have a problem, because if Brown was dominant, it would mask the recessive black gene, and that male would be Brown. He'd have a box just like that, and he doesn't. So this assumption is incorrect. So let's just take those out and return to another assumption, and let's assume, so it's a bit of a mess, let's assume big B is equal to black and small b is equal to brown. So we've just flipped those around. Let's see if that works. It may just be that you choose this first off, but let's go and have a look.
Is incorrect.
Again, I'm going to start with the offspring, and let's assign these two males their genotype. So to be brown, if Brown was recessive, there's only one possible way, and that's be homozygous brown. If there were the big B, he'd be black. And the same goes for this one. Now for this male, he got one small b from one of his parents and a small b from the other. That means each one of his parents gave him a small b. So let's assign those to the parents, small b and small b. But they're both black, so they have to be carrying the dominant gene, and there we have the answer. So heterozygous black crossed with a heterozygous black, it's possible that they have homozygous brown furred offspring. And it's also possible that they could have black furred offspring. Now, what's interesting here is that because the parents are heterozygous, there are two probabilities here. That one could be big B, getting a gene from dad and a gene from mom. So she is homozygous, black, but she could also be heterozygous. There's nothing to say that she didn't get the small b from dad or the small b from mom and the opposite from the other parent. So she could be big B, small b. What is important here is that if you asked for the genotype of this particular individual or that particular individual, you have to and you must include both possibilities. If you include only one, you're going to get no marks. That is important.